parameters for substation equipment selection. So the input design parameters for a substation is very much essential for selecting the substation equipments with proper sizing. So the fundamental design are very much essential for proper selection of the substation equipment. And this determines the ratings, configuration, reliability, and the future expandability of the substation. What are they? Their first one is your system voltage. This system voltage is the operating voltage level of the substation, and it may be 11 kV, 33 kV, 66 kV, 132 kV, 220 kV, or 400 kV, and other. And the voltage level of the substation determines the insulation level of the substation, and it governs the equipment rating, influences the clearance and layout dimensions. For example, for 132 by 33 kV substation, the equipment such as transformer, CTs, PTs, isolators, lighting arrestor is rated for the 132 kV and 33 kV systems. Second one is your maximum demand. Is the maximum demand. It is in MVA. What is the maximum demand? The maximum demand is the highest anticipated load the substation must supply. The working formula for the maximum demand MVA is as follows. That is your root 3 V in kV into I ampere whole divided by 1000. It comes out to be MVA. It determines the transformer capacity, bus bar current rating, cable and conductor sizing. For example, the load of 25 kilowatt MVA will convert to be at 0.9 power factor. This is 27.8 MVA. The transformer rating should be 31.5 MVA as the nearest standard or higher than that. Accordingly, the current rating of the bus bar may be calculated as 27.8 into 10 to the 3 whole divided by root 3 V 33 into 10 to the 3. This comes out to be 486 approximately. The utilities normally provide 20 to 30% above the normal value. So the minimum bus bar rating may be 630 ampere, and preferably it should be 800 ampere, taking future growth into consideration. 33 kV XLP square 400 mm square cable or equivalent may be preferred depending on the method of installation. SCA said overhead conductor current carrying capacity should be minimum of 630 ampere. Proper selection of the sizing of the overhead conductor depends upon the small length, temperature, and utilities. In third design parameter, the short circuit level, fault level. The short circuit level indicates the maximum fault current occurs at the substation. The working formula for fault MVA is equal to root 3 V in kV and I short circuit current ISC in kiloampere. The fault level determines the circuit breaker breaking capacity, bus bar withstand rating, CT thermal and dynamic rating. For system voltage for 11 kV, the fault level may be 25 to 40 kiloampere. For 30 kV system voltage, this comes out to be 25 to 31.5 kiloampere. For 132 kV, it comes out to be 31.5 to 40. For 2 to 220 kV, the fault level will be 40 to 50 kiloampere within that. For 33 kV voltage level, the fault level of 31.5 kiloampere, it needs a circuit breaker operating of minimum 31.5 kiloampere. The next design parameter is the load growth within the future 10 to 20 years. The future load expansion may be considered during the planning of the basis of the population growth, industrial development, commercial aspect, future feeders, additional transformers, and the planning of the future load expansion prevents the premature upgrading and reduces the future investment cost and ensures the uninterrupted service. For example, if the basic load is 20 MVA, the expected annual growth should be expected to 6% per annum, and we may calculate the future load after 15 years as per the calculation 1 plus 0.06 to the power 15. That will be approximately 48 MVA. And the substation should be planned accordingly for 15 years, 15th year expansion. So the type of substation also influences the selection of the equipments of the substation. If we prefer, if we choose the air insulated substation, it, it will have some certain advantages and disadvantages. The advantages are the lower, it is lower initial cost, easy maintenance, simpler expansion, and disadvantages are it requires large land area affected by pollution and weather. Then for GIS substation, gas insulated substation, it is very compact. Advantages are it is very compact, is high reliable and suitable for urban areas, less maintenance. And what is the disadvantages? What are the disadvantages? Disadvantages are higher capital cost, and it needs specialized maintenance. Then the last design parameter is the reliability requirement. The required level of reliability significantly affects the equipment selection and busbar arrangement. For utility and distribution substation, single bus arrangement may be adequate. For moderate reliability may do. And for industrial plant substation, it needs high reliability, duplicate transformers are unprovided. For data centers and critical facilities, very high reliability is required, and redundancy also essential. N plus 1 or 2 redundancy, double bus or breaker and a half schemes also required. For hospitals and airports, emergency backup system should be there, and dual power sources At last, we give some opinion that a well-designed substation starts with the accurate estimation of the voltage level, present and future load, all level, available land and required reliability, and these parameters form the basis of the selecting transformers and switchgear, bus bars, production systems, and overall substation configuration. So these are the details about the design parameters or input design parameters of the substation, which is very much essential to further calculate or select the proper sizing or rating of the equipments of the substations. For today, this much. Thank you.